Okay, so next topic is the letter B, direct variation and indirect variation. Again, just a few reminder if you need to take note of the other topics that we have here in physics, kindly access this Google uh, sheet. It is at the bottom of the title of this video. So you can just click the link and you will be directed on there. So you can access the lecture video, the sample questions, as well as the annotated physical worksheet. Okay, so let's see. So once we say it is uh, a direct variation, we talk about the relationship between the two variables, two or more variables that we see if it is going to increase or decrease in value. So sometimes we will encounter this kind of formula. Let's examine this equation. Pressure is equals to force per area. I think this one is the most common equation in physics. We define pressure as force per area. Notice that the pressure and force is in direct proportion. So once you say direct proportion here, pressure is force over area. The pressure in the left side of the equation, when you look at the force, it is also on the when you look at the variable of force on the right side of the equation, it is also the numerator part. So here you can see that the pressure and force they are in direct variation. And so we have that is symbol. Now take note we have area as constant. Now what do we mean by this? We say that as we increase the pressure, we will also increase the force. Okay? So increasing force three times will also increase the pressure or the P three times. Okay, so that is what we meant by a direct proportion. Now, how about if we focus on this equation, pressure and area are inversely proportional. Now, I want you to look on this case. Pressure on the left side of the equation is on the upper part, while the area is in the lower part. So you will say here that the pressure is inversely proportional to the area. So what does it mean? It means that as we increase the pressure, there is an increase in the area, or vice versa. As we increase the area, there will be a decrease in pressure, provided that the F is constant or not changing. So here in this case, if you have the area or have the area, pressure will be doubled. So the inverse proportional, it's they are inversely related. So if the one variable will gonna go up, the other will gonna decrease. Now, how about if you talk about force and area, if the pressure is constant, this time is quite different. We're given with this, right? But you want to look at the relationship between the force and area. Now, we can arrange this pressure is equals to force over area. You can watch my previous video. So area times the pressure is equals to the force. Now, you will see here that the area and force are directly proportional or indirect variation. So what will gonna happen on that? As you increase the A, the F will also be increasing, provided that the pressure will not be gonna change or the P is will not change or in constant. Now, this will gonna lead us to conclusion that doubling the area will require a doubled force if the pressure is constant. Now, how about this example number two? Let's try to look on this example number two and let's try to practice. Say for example, you don't know yet the equation for the work, but this time its work is force times distance. Now, how about the relationship between work and force? Now, for the work and force, work is directly proportional to the force. Work and force is in direct proportion. Now, how about if it is W and D? Now, if you look here, W is equals to FD. They are both on the same numerator. So work is directly proportional to D, provided that the force is constant. Now, how about the force and D or the F and D? Now, if we look here, if we derive for this part, we have work is equals to FD, divide both sides by F, so we can cancel out. That would be work over F is equals to D. And you will see here that the force is on the denominator part, and on the other side of the equation, the D is on the numerator part. So force is inversely proportional to D. So F and D, they are inverse proportion. Now, how about doubling W? We'll blank as the D as long as the F is constant. So meaning to say, if we have to look at the W and D, okay? So W and D are directly proportional. So therefore, doubling the W will double the D as long as the F is constant. Now, how about letter E? If D is quartered in a constant W, and so we are looking between the relationship of force and distance, or F and D. If D is quartered in a constant W, F is, so here, quartered, if D is 1/4, therefore F is, since they are inversely proportional, therefore F would be quadruple. Okay? So now, let's try to look at example number 3. Kinetic energy is defined as 1/2 mv squared. Now, again, if you're going to look here, kinetic energy, or KE, is a direct proportional to M. Wherein increasing the KE, we're going to increase also the mass, provided that the V is constant. Now, how about this concept? KE is also directly proportional to V squared, wherein M is constant. Note that an increase in KE will also increase in the velocity. Note that K and V are in a direct square proportion. They are not in direct proportion alone, but they are in direct square proportion. Now, how it will gonna affect our equation? Now, doubling V, it means KE is quadrupled. So if we're gonna look at this equation, doubling the velocity means kinetic energy is quadrupled. So this is the formula. Now, if we're gonna try to prove that in our mathematical equation, the V here, so we have your kinetic energy is equals to 1/2, and then we're gonna have M, and then we're gonna double the V, and then squared. Now, this time it will become kinetic energy is equals to 1/2 M, and then multiplied to 4V squared. Now take note, kinetic energy, factoring out the 4, that would be 1/2 mv squared. So I remove this 4 and putting it on this part, right? And so this is the original equation. So that would be kinetic energy is equals to 4 times of the mv squared. So that means if it is squared, doubling the velocity would would have 4 times the ke, and 3 times the velocity would have 9 times of the ke, and 4 times of the velocity we're gonna have 16 times of the ke. Now, how about the next concept? How about this one? Mass and the velocity are inverse square proportion where ke or k is constant. Now that means an increase in mass would be a decrease in a squared factor of v. What will now let's try to look at the equation. What will happen? What will happen if to the velocity if if the ke is constant and the mass is increased 4 times? Now we can have this technique wherein since kinetic energy is equals to kinetic energy, we could say that we have this 1/2 m1 v1. Take note of the 1 here, and then the v1, then the m2 and v2. Now, from the problem, we have mass is increased 4 times. Okay, so mass increase 4 times. So we have 4 times the 1 for the M2. And so if we're gonna look here, we can cancel out now the mass. So from here we could cancel out the mass 1 and the mass 1. And then of course we could cancel out the 1/2 until we end up with this V1 square and then 4 times the V square. And then we're gonna solve for the V2. So that would be V1 squared over 4. And then therefore V2 is now equal to square root of V1 squared over 4. And square root of V1 squared would be V1 over 2. And so this is the same as 1/2 of the V1. Now, let's try to look at the other question. Now, how about if the K is the same and the velocity is triple? This time, kinetic energy is the same and the velocity is tripled. What will happen to the mass? Of course, based on the equation, the mass should be decreasing 9 times, right? But if you want to prove it mathematically, here we have 1/2 m1 v1 square and then 1/2 m2 v2 square. And then we have here, now let's look at this. The velocity is tripled. So the velocity is tripled can be expressed as 3 times the v1. And so velocity is tripled. So v2 is 3 times the v1. That's 3 times the v1. That's what we substitute here. And so we squared it. So we have the 9v squared, 9 times the v1 squared. And then we need to cancel out the mass. It appears on the both equation. It appears, sorry, we need to cancel out the 1/2. And then the v1 will be canceled, right? So v1 will be canceled. And so we will be left out with 9 times m2, then m1, and then this time it is m2, divide both sides by 9, and therefore m2 is equals to m1 over 9. So that would be a decrease by a factor of times. Okay? Now, again, kindly try this problem set. You can pause the video and refer to the answers later. Problem set 1. And then we also have the problem set 2. So number 2, number 3, number 4, number 5, and number 6. Okay, thank you for listening.